Okay, hello guys, welcome to Circuit Cracker. In this video we will talk about supernode analysis. I have written the steps to be followed here, and I will explain these steps with the help of this circuit. Okay, what supernode actually is. If you get any voltage source between two nodes with unknown voltage, then it is called supernode. Okay, in this figure if I note down my nodes, this will be my node 1, another node 2, another node 3, and another node 4, and I will decide my reference node. If I decide my reference node here, then I will get unknown voltages at node 2 and node 3. I will get my unknown voltage at node 2 and node 3, and I have a voltage source between these two nodes with unknown voltage. This means I have a supernode. Okay, if I consider my reference node here, to avoid node 2 and node 3, to be a supernode, then still I will get a supernode, since I will have my node 1 and node 4 unknown nodes. That is, I will have a voltage source between two nodes with unknown voltages. So it is the typical example of supernode, and we will analyze it with these steps. Okay, step 1, node your nodes. I have already done this, as I have 4 nodes in my circuit. Decide reference node. I will decide my reference node here, not here. As soon as I decide my reference node in node 4, then I will get my voltage at node voltage to be 24 volt. Okay, at step number 3, reduce the adjacent nodes connected to voltage source to single node and apply KCL. That is, I will say here, reduce the adjacent nodes with unknown voltage. Okay, unknown voltage. Let me repeat my step number 3. Reduce the adjacent nodes with unknown voltages connected to voltage source. That is, I have 2 nodes with unknown voltages connected to the voltage source. I will consider my 2 nodes with unknown voltage and having voltage source in between them as single node and apply KCL. While applying KCL, I have to give the direction of current. I will call it as I1, and my direction will be from 1 to 2, I2 from 2 to 4, I3 from 3 to 4, and this I dash, that is I dash is equals to 3 ampere. Okay, applying KCL at supernode. This is my supernode. That is node 2 and 3. That means I will consider these 2 nodes as single node and apply KCL. Okay, this is, let me call this as my single node. So here is my equation. I1, this is going inward, and all others are going outward from this node. That is, I1 is equal to I2 is going outward from node 2, I3 is going outward from node 3, and I dash is going outward from node 3. Okay, I1 will equal to B1. Okay, I'll call it as B1, B2, and B3. B1 is equal to 24. I1 will equal to 24 minus B2 upon 2 is equal to I2 will equal B2 by 6 plus I3 will equal B3 by 8 plus 3. What we did here? We reduced our adjacent nodes with unknown voltages, that is node 2 and node 3, to single node. It will act as our single node. Okay. While applying my KCL, I'll get the equation as I1 going towards B2 is equal to I2 outward from B2 and I3 from outward from B3, I dash outward from node 3. While solving this, I'll get the equation as 2 by 3 B2 plus 1 by 8 B3 is equal to 9. Let's look at this node. You will get as many equations as your unknown node voltage. We have two unknown node voltage and I only get one equation. That is, you need to have two equations for two unknown node voltage, and we can easily get our another equation as B2 minus B3 is equal to 4 volt. Don't be confused at this. This is your terminal having higher voltage potential in comparison to this. So we can write B2 minus B3 is equal to 4. This is your equation 2. Now if I solve this equation, then I get the value solving I and II. I'll get the value of B2 is equal to 12 volt and B3 is equal to 8 volt. And you can find other parameters too by using these values. Okay, this much for today's video. In the next video we'll do another example of supernode analysis. Subscribe my channel and make sure you won't miss that next video. Thank you.